Hello students, so in this video we're going to do a couple of examples from the homework in section 9.1 on correlation. So I encourage you to read the book for more information about what correlation is all about and the different types of correlations that exist between two quantitative variables as shown in this figure. Oh, and I also encourage you to view the introduction to chapter 9, from the modules section of the course. So click on modules, scroll down to the very bottom of the page, and then click on the introduction to chapter 9. And the information on this page will give you a brief introduction to what we're going to cover in chapter 9. Okay, so I want you to read it carefully. Keep in mind that we're only going to cover sections 9.1 and 9.2, so we're not going to cover any of the other sections from chapter 9. Okay, so in the homework for section 9.1, the first two questions ask you some basic questions about correlation. Okay, so you'd have to read the section carefully to answer these two questions. And then problem 3 in the homework, you're asked to drag each of the scatter plots into the appropriate description. Okay, and you can find descriptions of these words, for example, perfect positive linear correlation, strong positive linear correlation, so on and so forth. Okay, at the beginning of the section, along with some examples. Okay, so I can encourage you to read the section carefully before beginning the homework. Okay, so the problem we'll start with is number 4. Okay, and it says that the accompanying table shows the ages in years of 11 children and the number of words in the vocabulary. Okay, and it says complete parts A through D below. Okay, so the table is the first link here. So the table of data, okay, is the first link. And then there's another table of critical values that we'll look at as we go through the problem. Okay, but it's the first link you want to click on. So click here to view the table of data. Okay, so here we have the age of randomly selected children from the population. Okay, that's the X variable, the explanatory variable, or the independent variable. Okay, which is age in years. Okay, and then we have the variable Y, which is the number of words in the vocabulary. Okay, so for example, the child who is 1 year old has a vocabulary size of 9. Okay, a child who is 2 years old has a vocabulary size of 260, so on and so forth. Okay, so the vocabulary size Y is the dependent variable or response variable. Okay, so we're going to go ahead and copy this data into StatCrunch. Okay, and a part A is asking us to display the data in a scatter plot. Okay, so what we're first going to do is copy the data and then create a scatter plot of the data. Okay, so in StatCrunch, I'm going to go ahead and paste it at the very top row. Okay, where it contains the names of each column. Okay, so again, the X column is the ages of these children, and then the Y column is the vocabulary size for each of these children. Okay, so this is an example of paired data. Okay, so the age of each child is paired with their corresponding vocabulary size. So when we want to determine, right, the kind of relationship that exists between these two variables, okay, we want to create some sort of graph, right, to get an idea if there's any kind of pattern that we can identify. Okay, so let's go ahead and go to graph, and we're going to select scatter plot. Okay, so the X variable are the ages of these children, X, and then the vocabulary size is the Y variable. Okay, and there are many different options which you're not going to worry about. Okay, so we're going to display the data as points in our graph. Okay, and you can select other options such as having the points be filled circles, hollow circles, or transparent circles. I'm going to leave it as a filled circle, and then you can adjust the size of the points in your scatter plot. I'm going to leave it as 2. Again, there are many different options. Okay, you can even add labels, so the x-axis label would be the age in years. Okay, and then the y-axis label will be the vocabulary size. Okay, so the age is X, vocabulary size is Y. I'm just going to click compute. Again, this is optional. We don't need to put that in for the scatter plot. Okay, and this is what our scatter plot looks like. So you can see that on the horizontal axis, we have the age of each children. And then on the vertical axis, we have the vocabulary size. Okay, so remember, each dot in the scatter plot represents one individual. Okay, so if you place your cursor over one of the dots, right, it'll tell you in which row of the table that the data value is in. Okay, and it gives you the x and y value. In this case, the y value comes first, and the x value is second. Okay, it should be the other way around, right? Because the x value usually comes first, followed by the y value. Okay, but if you put your cursor on each dot, it'll tell you the x and y value, and then the row of the table that data value belongs to. Because, for example, this dot here represents a child who is 4 years old, and whose vocabulary size is 1,100 words. Okay, so we're going to select the appropriate scatter plot. Again, the one that most looks like the one we just got. Okay, and they all look very similar. Okay, but go ahead and select the best answer. Okay, it's obviously not this, right? The points don't slope downward, right? All the points slope upward. Okay, so A and C can be eliminated, right? Because the points in our graphs have an upward sloping pattern. Okay, which might indicate that there's a positive linear relationship. But in any case, right, select the best answer choice for your scatter plot. Okay, the next we're going to calculate the sample correlation coefficient R. Okay, so the value of R is going to give us an indication of the strength of the linear relationship between the two variables, okay, age and vocabulary size. Okay, so we're going to go to the stat menu. Okay, go to summary stats and then select correlation. Okay, so we're going to select the columns that contain our data. So the age X, vocabulary size Y. All right, and we can decide to calculate a p-value, but let's go and leave that unchecked. Okay, what we're looking for is the correlation coefficient, okay, which is this number here. Okay, so remember, correlation coefficients, right, are always between -1 and +1 inclusive. Okay, the closer the value of the correlation coefficient is to either +1 or to -1, okay, the stronger the linear relationship is between the two variables. Okay, and because the correlation coefficient here is 0.976, okay, that's fairly close to +1. Okay, so what that's telling you is that there's a strong positive linear relationship between the two variables, okay, age and vocabulary size. Okay, so let's go ahead and enter that as our answer, rounded to the appropriate number of decimal places. So we're going to round correlation coefficients to 3 decimal places. Okay, so 0.976 would be the answer. Okay, in part C it says to describe the correlation, if any, and then interpret the correlation in the context of the data. Okay, so we already know our scatter plot indicates that there appears to be a strong linear relationship between the two variables. Okay, we confirm that with our correlation coefficient, which is 0.976. Okay, it's positive and it's close to +1. Okay, +1 is the largest R could be. Okay, so if there's a perfect linear relationship between the two variables, then R would be equal to 1. If there's a perfect negative relationship between the two variables, R would be -1. Okay, so on and so forth. Okay, but R is fairly close to +1. Okay, so that confirms that there is a strong positive linear correlation, so select the best answer based on your scatter plot and the value of R that you're getting. Okay, and then it asks us to interpret the correlation and then choose the correct answer. Okay, so if there's a strong positive linear relationship, that means that as the x value increases, the y value also increases. Okay, so remember, x is the age of the child in years, and then y is the vocabulary size. So you want to read the answer choices carefully and then select the best one. Okay, so the thing you want to remember is that that correlation does not imply causation. So in this example, even though there's a strong linear relationship between the two variables, right, it doesn't mean that age causes a child to have a larger vocabulary size. Okay, that may not be the case. Okay, so we know we're going to eliminate answer choice C because that's what answer choice C says. Okay, so correlation does not imply causation, right? One variable is the cause of the other, because sometimes that's not the case. Okay, answer choice B says as age increases, the number of words in a children's vocabulary tends to increase. Okay, which is the correct observation or interpretation. And again, it doesn't tell you why that's the case, right? Why there appears to be a strong linear correlation between the two variables, age and vocabulary size. Okay, now there could be as the older the child gets, the more they learn. Okay, the more education they have. Okay, the more likely they are to have a larger vocabulary size. Okay, so that might be the explanation, but once again, age is not the cause of the vocabulary size. Okay, so on to the next part here. So part D says, use the table of critical values for the Pearson correlation coefficient to make a conclusion about the correlation coefficient. Okay, so in other words, it's asking you to perform a hypothesis test. Okay, so when you do the hypothesis tests in this section, okay, we're going to use the table of critical values. Okay, and part of the table is here. All right, and so basically you find your sample size n, and then you choose the correct level of significance, whether it's 0.01 or 0.05. Okay. And then you find the critical value in that table. And then based on that critical value, you decide whether to reject or fail to reject the null hypothesis. Okay. So the question is, right, what are the null and alternative hypotheses for the hypothesis tests in this section? Okay, and you can find that information at the top of page 478. Okay, but in any case, let's go back to the question. Okay, so the critical value is blank. Okay, so we know that there are 11 children in our sample. Okay, and our significance level is 0.01. Okay, so clicking on the table there, okay, for a sample size of 11, at a significance level of 0.01, our critical value is 0.735. Okay, so 0.735. Okay, and we can see that the absolute value of our correlation coefficient is 0.976. It's clearly larger than our critical value. So therefore, there is sufficient evidence at the 1% level of significance to conclude that that there's a significant correlation between children's ages and the number of words in their vocabulary. Okay, and that completes problem 4 in the homework. Okay. So before I end the video, I do want to mention that when you do these problems in section 9.1, right, if you end up with a negative value of R, okay, ignore the negative sign, right? So take the absolute value of your correlation coefficient. Okay. So in other words, if this were like negative 0.976, right, we would simply ignore the negative sign in front of it, all right, and then compare the number, okay, to the critical value. Because you notice that in the table of critical values, right, these numbers are all positive. So the critical values will always be positive. Okay, so if you get a negative value for the correlation coefficient, okay, remember to ignore the negative sign and then compare the number, the value of R rather than the sign, right? They compare the value of R to the critical value to determine whether or not to reject the null hypothesis.